Welcome back to Trader UK, the money management channel. Today I have a new company to share with you, a company that I've been adding into my portfolio recently. This company has a £1 billion or so market cap, so relatively small cap, and they operate in the renewable energy or clean energy sector. Operating out of the UK, they specialise in fuel cells, a term you'll recognise if you invest in Tesla or renewable energy electric vehicle companies. However, that is one of their applications. This company, though, I'm very interested in because it has massive application potential in a residential setting, so powering your home. So in today's video, we're going to run through a few different things. Firstly, we'll look at the name of the company, and then I have a video with a little bit of commentary to explain what their technology is, why it's so important, how it can be used, and how it is being used around the world. Remember, this is not a concept. This is a working company, working product on the shelf. Secondly, we'll run through the financials and a little bit about the performance of the stock price over the last year or so. And then finally, I'll tell you where I think this one is going, how I think it will perform in the future. Before we do get into this, as always, if I can ask you to like the video for me and don't forget to subscribe to the channel for more similar content. Now I'm going to bring this up on screen for you now. The company is called Ceres Power Holdings, ticker symbol CWR. This company has spent 15 or 20 years perfecting a power cell made from steel and ceramic paint, so easily available, readily available materials are already mass produced. We're going to watch a quick video from 2017 by Fully Charged. I don't know if anyone's ever watched that program in the UK. You're probably familiar with it. They explain better than I can exactly how that fuel cell can be used by mass market.
Hello and welcome to another episode of Fully Charged. This week coming from Horsham in Sussex. Lovely rolling countryside of Sussex, but in fact we're in this amazing fabrication plant which belongs to a company called Ceres Power. Now, what does Ceres Power do, you might ask? Well, I'll tell you what they do. They make fuel cells. Now, did you notice how I said that? I didn't say hydrogen fuel cells, I just said fuel cells. What they make here is world leading, literally the global leader in the field. There's people coming here from all over the world, from China, from Japan, from America, to look at what's happening.
He's right when he says that, about it being world leading. I'm going to show you some of their partners in a minute, the big name partners that they're already attracting, and you can see how advanced this technology is.
In Horsham in Sussex. And so I'm going to have a look now, and to do that I need to put on a special hat that's very exciting. How do I look? So Phil, thank you very much for giving us some time today. Can you just go through the real rudiments for a thicko like me? You make fuel cells.
So very simply, it's almost like a continuous battery. If you give it fuel, it gives you power, but it's doing it incredibly efficiently.
I naturally think of sort of gas. You get gas and you burn it and you produce heat, but you're not burning anything.
No, we're not. This is an electrochemical process, and that's what makes it highly efficient. In fact, we can generate power at the point of use, so in your home or in your business, that's more efficient than the grid.
Right.
So the fuel cells we've got here generate power from gas.
A very important point in terms of efficiency, this system allows you to generate power and heat on demand where it is needed, rather than producing tons and tons of power and saying to everyone, take what you need. It's on-demand power, so increases efficiency.
To power out at more than 50% electrical efficiency. If you think about our grid in the UK, it's about 35% efficiency, because we waste a lot of energy through cooling towers, through transmission, distribution, etc. A lot of the fuel cells that we're seeing in installations today, in things like data centers in the US, in homes in Japan, starting to get into offices and buildings, run on conventional fuels. And the kind of technology we have here at Ceres runs on everything from natural gas to biofuels to hydrogen. So we're totally fuel flexible.
You could have literally the same machine could run on all those three.
Yeah, that's correct. You might make some slight adjustments to the system, but essentially the cell can deal with all those. A lot of people might say, well, that's not zero carbon.
So a fuel flexible product, very important. People will have peace of mind that they can spend money on this equipment and it's not going to outdate as fuel sources change. If it has to be used with natural gas for now, great, it's ready for that. If times change and we transition to hydrogen, the product is also ready for that as well.
But it has a hell of a lot of benefits because it's low carbon. Like in a home application, you're saving about a third of your energy, and therefore you're saving about 30% of your CO2. And also with this kind of technology, your zero emissions, your zero SOx, your zero NOx, and your zero particulates.
If you did have a supply of hydrogen from splitting water from excess renewables, can you put just hydrogen into the system that you're running and it will still run?
I mean, the cells we're making here, we test on hydrogen.
Right.
So we could run on everything from 100% gas to 10% hydrogen in the gas grid,
right.
50%, all the way through to 100% hydrogen.
Worth noting that although these systems might run on natural gas or biofuels or hydrogen or maybe a mixture of those for some time, they don't actually burn any of that input. It's all via a chemical reaction that they generate the power. So, as well as being more efficient, they're also a lot cleaner, the energy that they do produce.
While it's functioning, while other things develop.
Yeah, we're dealing with a lot of companies who are looking at alternatives to conventional combustion engines and diesel engines.
Yeah.
And a big driver for this technology now is air quality issues. And what we do at Ceres is we make the core fuel cell, the steel cell, but we embed it, a bit like an Intel Inside, we embed it in the future power systems of these global companies. So you can use this to power a data center, you can use it as a range extender for electric vehicle, you could use it to power your home, or you could use it to power a business. The technology
In a moment, we'll take a look at the real-world applications of this technology and how it's being used, because although this company has a very small turnover, it's actually represented really well around the world on a global scale. So we'll take a look at how they're doing that.
Imperial College over 15 years ago, a guy called Professor Brian Steele. What he did, which is really clever, is he took steel and managed to make a fuel cell which is over 90% steel with a very thin layer of ceramic to do the function of the fuel cell printed on top. And that's essentially the steel cell that we have today.
It seems to be one of the things that were holding back sort of mass adoption of fuel cells is the cost of the materials in it. So what are the materials that you're using here very expensive?
It's a combination of using low-cost steel. We don't use precious metals, we don't use platinum, things like that.
There's no precious metals at all.
We use a conventional ceramic, which is used in self-cleaning ovens, etc. But then we're producing it on equipment which is adapted from the solar PV industry. It's a combination of available materials and conventional manufacturing.
Available technology in a way.
Yeah.
Right.
If we were
One thing that I love about this technology is the fact that the materials they use, the input materials, are readily available and very cheap to source, but also they talk about their factory. All their equipment is kind of off-the-shelf repurposed equipment. There's no need to design and build specialist equipment, which means scaling up will be very, very easy for them.
in Japan, you would have adverts for this on TV now,
Right.
and you could buy one in your local gas showroom.
Yeah.
And they've sold about 150,000 of these things already.
Wow.
And they have a target of 1 million installed by 2020 and 5 million by 2030.
Wow.
And just to get that in context, that's the equivalent of a Hinkley Point, but faster and cheaper
Yeah.
than we'll ever see Hinkley come online,
Yes.
probably.
Yeah.
Germany's now following suit. So the German government are offering good incentives for fuel cells there. And that's really about balancing renewables with distributed generation.
Yeah.
So what this technology does is it enables more renewables onto the system because it can deal with the
Peaks and
intermittency.
troughs. Yes, yeah.
If you had a technology that would enable you to generate the power in your home at the point where you need it, you'd have it.
Yeah.
And that's what this technology does. So the conventional generation is being disrupted. I mean, my view is in the future you've got solar, you've got batteries, you've got electric vehicles, and you'd have fuel cells.
Yeah.
And all these parts of the energy system would work in a very complementary fashion.
Right. I mean, it's an impressive setup you've got in here, but it is, I can tell it's still on a relatively small scale. So this could be you could have a gigafactory.
Yes. This is our first step towards a gigafactory. Yeah. It's the mega factory.
This is just a gig factory.
Yeah.
So hopefully that explains a little bit more about what their technology is and how it can be used. Now let's take a look at the real world applications of how this technology is already being used and sold around the world. So what we have here is a very effective, very adaptable product. As fuel sources change over time, so does the product. It can run on different fuel sources. And you can see on the screen there's already a number of applications for this. So residential properties, first of all, you can install these to power and heat your home in one system. If you think about it, normally, certainly in Europe anyway, and I think most places, you tend to have two systems on the go. You'll have electricity coming from the grid to light your home, to power your appliances, and then you have mains gas running into the home, powering a boiler, which in turn runs a central heating system and gives you hot water throughout the home. This combines the two systems in a much more efficient way. Electric vehicles is another market that can utilize this technology. Ceres have already developed a range extender for electric vehicles. If you think about heavy payload commercial vehicles, in the early stages, the range is going to be a little bit limited, so these two technologies will work very well together. And then it says about data centers. Now, I think this could be a big win for them and quite an easy win as they already operate in this market. I did not know this. It says that data centers already account for 2% of electricity usage globally, which is set to rise to 8%, fourfold by 2030. And clearly, the technology is very well suited to this area. If you think about those data centers, they can't have diesel-powered, petrol, gas-powered generators creating lots of fumes. They need clean air running through and cooling their data system. So this technology is perfectly suited to that. And then it mentions distributed generation. So this is really important. At the moment, we don't have a very efficient system. If you think about it, most countries will have big power stations dotted around that generate the vast majority of a country's need for electricity and power. That power is then distributed across the country through overhead wires, through underground cables, etc., that need a lot of maintenance, big infrastructure cost as well, that if there is bad weather, get damaged quite often. Why not change that and have millions of miniature power stations dotted across the country, in people's homes, in people's offices, in their vehicles? It makes much more sense and it's much more efficient this way. Now, we'll take a quick look at the share price performance via Trading 212. Amazing performance recently, over 1,400 per share. Anyone unfamiliar with the UK market, by the way, 1,400 is pence, so it's £14 per share, not £1,400. Performed very well in the past year, about 250% up. 191 employees, so a very small company, this one, but with a market cap of 1.2 billion, which looks out of line with their turnover, which is only 18.9 million pounds. A lot of you will be wondering, why are you so excited about a loss-making company that has a valuation that's 60 times its revenue figure? And I'm going to share some graphics with you on screen and talk through them, which will hopefully explain that excitement. First of all, let's take a look at some of these partners here that Ceres have on board. And it's important to note that these aren't just customers. A number of these companies, big companies, are actually shareholders in Ceres, so they have a vested interest in using their products moving forward. All big international players in their respective field. Bosch, I believe, German-based, very well established across the world, in particular Europe and the US. Weichai are the third largest commercial vehicle manufacturer in the world. And as well as being a customer, they actually have a joint venture with Ceres in China, which of course is going to be a very big market. Doosan, another international company, they want to utilize Ceres technology for the Korean market in particular. Amira of Japan, who are actually already producing, they're the company that are selling the combined heat and power units for homes in Japan. Next up, just a couple of interesting numbers from their financials. We won't go through the full accounts because they're not that detailed at the moment, although turnover is only 20 million at the moment, or just under. Gross margin, 73%, very high. The reason the margin is so high is because this company don't really focus on manufacturing of their technology. They do have a plant in the UK and they have some output, but they recognize that renewable energy demand worldwide and cutting carbon emissions is an unimaginably large task, so they need the help of global partners like we saw in the previous screen, who have that infrastructure, who have the balance sheet, who have the cash to implement their technology on a global scale, so that they can act more under a licensing model. Companies will pay Ceres to license their technology so that they can manufacture it themselves and use it in their own products, which is a hugely profitable model. And once they've developed the technology and sold the license, the rest of the cost is of manufacturer. Is incurred by their partners, essentially. You can also see here that they have a very healthy cash position, 108 million as of June 2020, and they should be able to use that cash position and those strategic partnerships to capitalize on the green economic recovery, which should be benefiting them directly. So you can see here a number of nations that have announced a green stimulus package. You'll notice every one of these nations on here that have announced this package, Ceres already have representation in those areas, in the United States, in Europe, in Korea, in China, in Japan as well. That's why they have those strategic, big name global players on board. And then this final image really helps me to demonstrate the company's business model and why they're going to become more and more profitable over time. This is the 3-step process they undertake with partners, and these are new partners they took on over the past year or so, and it shows where they are in that process. So step 1 is joint product development, where the two companies will work together. They'll approach Ceres, start working together, build prototypes, etc. Make Ceres' existing technology fit the end product, use their fuel cells in whatever the customer has it in mind for. Lots of this work going on at the moment, but it's very labor intensive, lots of engineering, and they don't make as much of a margin at this stage. Then you can move on to step 2, which is when you've already proven that the product works. So the customer will then pay Ceres a license fee to use technology. They're going to pay X amount per year so that we can manufacture your patented steel cells in our factory in Japan, for example. This is very high margin income, as there isn't much cost involved with the actual licensing, but it only really involves maybe a one-off payment or probably an annual payment for the license fee. And then finally, we move on to step 3, the real money maker. Royalties received when the customer sells their products to the end user. For every combined heat and power unit that they sell in Japan, for example, Ceres will receive a royalty fee. For every range extender that they sell in China, Ceres will receive a royalty fee. This is where they make the money. It's very high margin and there is no limit to the income. The more successful the customers are, the more successful Ceres are, and that's why I like this model. What you can see though from this image is that they are only just starting to filter their customers through steps 1 and steps 2 and into the final step. This is why I believe that the company is about to hit that exponential growth curve in terms of revenue, in terms of profitability, and the share price as well. So where do I think this company is going? Where do I think the stock price is going? I think this is a buy and hold, 5 years plus, but it is a 10x opportunity without a doubt. The underlying business is going to perform very well. Revenue is going to increase sharply over the next few years. Gross margin will stay very high. They'll continue to take on more big name partners. And because of the type of business model that they've taken on, a licensing model rather than a manufacturing model, that's going to allow them to focus on the technology, which is clearly what they're very good at, to develop new technology and new products to accompany that technology as well. Now is a good time to invest in this company, in my opinion. I think just because of the type of company, the sector that it's operating in, it is an investor's dream sector, and institutions are really going to get on board with this one as well. So it's an absolute buy and hold for me, but long-term outlook, 5 years plus. That is everything for today, guys. Let me know your thoughts down in the comments. In particular, if you have been holding this stock already, I want to hear from you. Thank you all for watching, and I'll see you next time.